So let's talk first about conveyor systems that are used for sorting purposes. These are generally found in airports to distribute luggage, or maybe in companies such as UPS or FedEx to distribute parcels in their facility. On the library we are offering here, we have built the infrastructure so you can do two main things. One of them is to read from an external file all the coordinates of a conveyor network or multiple conveyor systems in order to build it automatically in AnyLogic. And the second one is to be able to connect with an external server that will reroute the objects in the conveyor system or will reprioritize them in the way that best fits the purpose of the company that is using this. So in this video, we want to show a demo on how this works and how to use the library in general. So let's get started.
This layout of conveyors was completely made using an Excel file. It was not necessary to draw the conveyors one by one, but there is even more. Spurs, transfer tables, sensors, and routes for the agents are not defined here in AnyLogic, but in an Excel file. Okay, so we are here in AnyLogic Cloud, and we're going to watch a quick demo of the sorting conveyors library. Let's run this model. We have to upload a configuration Excel file. So I have here 4 configuration files, each one is different from the other, and each one of these Excel files has all the necessary information to create the layout of the conveyors. I have here one layout, and if I go back to the menu, I can upload a new configuration file and you will see a new layout. Let's go back to the menu and I'm going to click the first one, run the model, and okay, this is the layout. You can see a lot of colorful conveyors and you can select the routes of the agents. A route is a sequence of interconnected conveyors that allows agents to follow a predefined path set by the user. This route is configured using the Excel file, where the user specifies the exact path the agents should take. By linking conveyors together, agents can move without problems from one conveyor to another based on the instructions provided in the file. This setup automates the flow of materials or agents efficiently. The route 0 is selected. I'm going to select now the route number 6. So the agents will go through these 2 routes, and I'm going to increase a little bit the rate. Let's run the model. And as you can see here, there are 2 conveyors, the red and the brown one, and the boxes are going through. And they are converging in one conveyor, which is the green conveyor. Here we have 2 output sensors and 1 input sensor. This will help to decide which one of these boxes or agents are able to go through the green conveyor. So in this case, the number represents the priority, so the red box will be able to go first, and then the blue box with priority 2 will have to wait. And now these 2 blue boxes are able to go through the green conveyor. Now, since we only have boxes in one conveyor, all the boxes are able to go through the green conveyor. So in this case, the blue box with priority 1 will have to wait because there are more boxes with high priority in the red conveyor, and that's it. So now you can decide in a convergent conveyor which agent has the priority to go through a new conveyor when having different priorities or characteristics for the agents. So this is one important feature that we are introducing here in this conveyor library, which is the priorities for the agents when you have two or more conveyors converging in one conveyor. Let's take a look at this new library. Here in the palette you will see a new icon, which is the sorting conveyors, and this library has a lot of agents. We are only using the first 4. The first agent, which is conveyor network settings, has all the things related to the client-server connection, and as well the token. The second one, conveyor network animation, has all the information related to the layout, so this agent is directly connected to the Excel file. The third one is conveyor network logic, which is the flowchart block that you can use in your logic, and here you can define some actions. And finally, special conveyor item, which is the type of agent that all agents using this library have to be extended from. So for example, in this model, I have a box agent, and here the agent is extended from this special conveyor item. Now I will introduce you the second feature, which is the client-server connection. I will run this Python file, which is the server, and even though we have created this server in Python, can be created as well in Java, JavaScript, C# and more. This is depending on your preferences. And when the server is running, I can go to AnyLogic and run the model. In this case, the model is the client. You will see the layout here with all the conveyors, but there are no boxes or agents in the system because there is not a source here. So we will inject the boxes using this HTTP protocol. Let's click this button and we will see the boxes appearing in this blue conveyor. What this button does is send data of the current state of the system to the server, and then the server decides what to do. In this case, injects 2 agents in the system with a defined priority and a sequence of conveyors to follow. The boxes have a priority, which is shown here in the 2D visualization, and this gives the user completely freedom to choose whether you have to inject more agents, define the priority of the agents, and as well the routes that the agents will follow. So clicking here on this button, you will see that more agents are being created.